In number 21, we can pretty clearly see two distinct parts to our integrand. X is being multiplied by e to the negative x squared. And within those two parts, I'm looking for one part that might be the derivative of the other or closely related to it. And because I've got an x squared up there in the exponent and then just plain x out in front, I think I know where I'm going with this one. I'm going to let u equal the exponent right here, negative x squared. We're going to differentiate both sides of that equation and get du is equal to a negative 2x dx. So my primary substitution is right here. My secondary substitution, it needs to cover the x and the dx, which I almost have here, but I need to get that negative 2 out of the way. So I'm going to divide both sides or multiply it by a negative 1/2. So a negative 1/2 du is going to equal x dx, and that's what I needed for that secondary substitution. So where are we right here, guys? This integral now becomes primary substitution is now going to be e to the u power. And then the secondary substitution, the x times dx, is a negative 1/2 du. I get that information from right over here. The du, I'm going to put at the end of all that, and the constant factor, negative 1/2, I'll go ahead and move all the way out in front of the integral. So we've accomplished everything here. We've gotten all of the x's represented in terms of u's, and we now have a much simpler integral to evaluate than we had prior. So this will be a negative 1/2 times, and the antiderivative of e to the u is just going to be e to the u. That was pretty simple. It's an indefinite integral, so there'll be a plus c at the end of all that, and now we just need to resubstitute back at the end right here, guys, to make this a negative 1/2 e to the negative x squared power, and we'll put a plus c at the end of that and be done. That should be our answer right here. And this is one that isn't really that hard to check your answer for by taking the derivative of what we just came up with. So for the derivative of an exponential function, I'd start with the same coefficient, negative 1/2, times the same base, e, times the same power, negative x squared, but multiply that by the derivative of the exponent, which would be a negative 2x. And now fun stuff happens. The negatives cancel, the 1/2 and the 2 cancel out, and we end up with x times e to the negative x squared, which is exactly what our original integrand got us right there. So that tells us for certain that we got this problem right here in number 21.